Hello engineers, welcome back. In the previous video, we got a theoretical understanding on the concept of recursion and the recursion framework. In this video, let's practice that concept using a lead code question, which is the Fibonacci sequence. Okay, let's get started. So in this video, we'll solve this easy question, Fibonacci number. The Fibonacci numbers, commonly denoted as f of n, form a sequence called the Fibonacci sequence such that each number is the sum of the two preceding ones, starting from 0 and 1. Okay, f of 0 is 0, f of 1 is 1, and for anything that is more than 1, f of n becomes f of n minus 1 plus f of n minus 2. So if you look at it, so this is the Fibonacci sequence. So the first one is 0, the second number is 1, the third number onwards, we get the number by adding the previous two numbers. So 0 plus 1 becomes 1. Now 1 plus 1 becomes 2. 2 plus 1 becomes 3. 3 plus 2 becomes 5. 5 plus 3 becomes 8, and so on. So if I want to get the 0th Fibonacci number, I go to here. So this is like a 0 indexed array. 0, 1, 2, 3, 4, and so on. So if I want to get f of 5, I get by doing f of 4 plus f of 3. Right? That's what it says. F of n minus 1 plus f of n minus 2. So f of 4 is 3, f of 3 is 2. So if I do 3 plus 2, I get 5. So that is my value. Okay, so that's how this goes. So let's try to solve this using recursion first, using the recursive framework, and then we will analyze the time complexity and see how that goes. So as we know, we need to build three pieces for the recursive framework. First is the base case. So as we discussed before, base case is the smallest value or the smallest subproblem for which we already know the answer. In our case, we have these two elements. These will never change. This is the first element. This is the second element. These will never change because that is how the sequence starts. So when we are trying to get a big problem, let's say we are trying to get f of 8, we can reduce it to this subproblem, and when we reach this end, 0 or 1, we get our base case. Okay, so that is our base case. And what will be our recursive case? Recursive case is simple. This is the recursive case. We need to call recursion on n minus 1, and we need to call recursion on n minus 2, and the operation will be whatever we get here. Let's say we get answer A here and B here, we simply do A plus B and return this value. That's it. So that will be our simple recursive code for getting the nth Fibonacci number. So let's code it. So first is the base case. If n equal to 0, then we simply return 0. If n equal to 1, then we simply return 1. These are my two small values for which I already know the answer. Okay. Next, what will be my recursive case? Recursive case is I need to call Fibonacci function on n minus 1, and I need to call the same function on n minus 2. And let's save these values. Let's say int a is this, int b is this, and now let's do the operation. Let's say answer equal to a plus b, and we simply return answer. Okay, so let's run and see. and it is working fine. Okay, and it is accepted also. You can further simplify this code like this. If n equal to 0, return 0. If n equal to 1, return 1. And if there is anything else, you simply do return fib of n minus 1 plus fib of n minus 2. That's it. 3 lines of code. And it is accepted. Now let's analyze the time complexity. So if we see here, for the first two numbers, there is nothing else to do. So this is, let's say, O of 1. But everything greater than 1, for every n that is greater than 1, we are doing 2 calls, right? For every n, we are doing 2 calls. So the number of function calls is dependent on the input size. So if the n is 2, function calls are 2. If the n is 3, 3 will call on 2 and 1. 2 will call on 1 and 0. 1 will call on 0 and minus 1. So there are 4 calls happening here. So number of calls is 4. If the n is 4, 4 will call on 3 and 2. 3 will call on 2 and 1. 2 will call on 1 and 0. This 2 will again call on 1 and 0. This 1 will call on 0 and minus 1. This 1 will again call on 0 and minus 1. This will call on minus 2 and minus 1. So there are total of 8 calls. Okay. As you can see here, the number is growing 2, 4, 8. This is 2 to the power 1. This is 2 to the power 2. This is 2 to the power 3. Right? So the time complexity is 2 to the power n here. So for every function call, we are making 2 to the power n function call. So that is a time complexity, which is very bad. So although we can solve this question using recursive, a framework, for a very large number, this can be very time consuming. So it can lead to bad performance. So the simple way to do it is using a simple loop like this. Now we know the base case 0 and 1. So what do we do? For anything that is greater than 1, we need to sum them up, sum the previous two numbers and return it, right? So let's keep a current tracker and let's use a loop for int I equal to 2. It starts from 2, anything that is greater than 1, and it goes all the way up to n. What am I doing? I am simply doing, let's save the first two elements here. Int num1 equal to 0, int num2 equal to 1. So our sequence starts here. Now when the current index is at 2, I simply need to do num1 plus num2 and I will return. Okay, when n is 2, I simply need to do n minus 1 plus n minus 2 and I will return cur. For anything greater than 2, I need to change these numbers. So num1 becomes num2 and num2 becomes current number, and that's it. Let's run it and see. So this is accepted as well. So what is the time complexity of this? This is O of n, right? There is a single loop which is traveling all the way up to n, and inside there are just constant operations. So this is O of n. So this is a better solution than our recursive case. So I'm just trying to show you that there are multiple ways to solve a question, and sometimes using recursion may not always be a good idea. But since we are practicing recursion, this is a good and simple example to create the framework, how to build the base case, how to build the recursive case and the operation, right? So that way we have solved uh, one question using two approaches, and this is a better approach. This is often. Okay. So that's it for this video, guys. If you have any questions, you can definitely ask me. And please don't forget to like the video, subscribe to the channel, and bookmark the playlist. I will see you in the next one. Thank you. Cheers.